Alright, so in this lesson I discussed three different characteristics of atoms: their atomic radius, their ionization energy, and their electronegativity. The general trend, and there are obviously going to be some exceptions, but the general trend for atomic radius is that as you move across the periodic table, atomic radius decreases. And it decreases because you're increasing the number of protons. And by increasing the number of protons, the attraction for electrons will increase, causing the electrons to be brought towards the nucleus, decreasing the size of the atom. As you move down the periodic table, atomic radius tends to increase. And the reason why is that you are increasing the number of principal energy levels. So with each principal energy level, 1, 2, 3, 4, all the way down, the electrons are going to be further and further away from the nucleus, causing the atomic radius to increase. Now, ionization and electronegativity, those both are inversely related to atomic radius, meaning the larger your atomic radius, the smaller your ionization energy is, and the smaller your electronegativity is. Electronegativity is simply the attraction for electrons, so it makes sense that the larger your atom is, the weaker its attraction for electrons are because they're further away. Similarly, ionization energy is the energy required to remove an electron. So the further electrons are from the nucleus, the weaker the attraction is going to be, and therefore the less energy is going to be required to remove that electron. All right, so let's look at some examples just to make sure we understand these trends. So which has a larger atomic radius, sodium or magnesium? Well, since sodium is further to the left and therefore it's going to have a larger atomic radius because it has fewer protons. All right, let's look at the next one. Which has a larger ionization energy, bromine or iodine? Well, if you look at your periodic table, bromine is higher up on the periodic table than iodine is, which means it is smaller, it has a smaller atomic radius because it has fewer principal energy levels. So since it has fewer principal energy levels and it has a smaller atomic radius, that means its ionization energy is going to be larger because remember, ionization energy and atomic radius are inversely related. So for number 3, it says, which has a smaller electronegativity, aluminum or sulfur? So if you look at the periodic table, aluminum is larger, it has a larger atomic radius than sulfur does because it has fewer protons. So since aluminum is larger than sulfur, that means that it is going to have a smaller electronegativity than sulfur does. So for number 4, it says, which has a smaller atomic radius, fluorine or chlorine? Well, fluorine is higher on the periodic table than chlorine, which means that it has a smaller atomic radius. But the reason why is that fluorine has fewer principal energy levels, which is why it has a smaller atomic radius than chlorine does. All right, let's look at the next one. Which has a smaller ionization energy, oxygen or fluorine? So if you look at the periodic table, right, oxygen is going to have a larger atomic radius because it's further to the left, it has fewer protons. So since it has a larger atomic radius, that means it's going to have a smaller ionization energy. All right. For number 6, which has a larger electronegativity, chlorine or iodine? Well, chlorine has a smaller atomic radius because it has fewer principal energy levels, which means it is going to have a larger electronegativity. Right, for number 7, why does lithium have a much larger second ionization energy than beryllium? Okay, well, lithium has one valence electron. So to remove the second electron is going to require a lot of energy. Meanwhile, beryllium has 2 valence electrons. So it's pretty easy for it to lose the first 2 valence electrons, but the third electron is going to require a lot more energy. So why does lithium have a much larger second ionization energy? Because it has 1 valence electron, and to remove that second valence electron requires the removal of a core electron, while beryllium has 2 valence electrons, so it's easy to remove those 2 valence electrons. All right. And then for the last one, there will be a large jump between which ionization energies for calcium? Explain how you know. Well, I know that calcium has 2 valence electrons, so to remove the first 2 electrons is not going to require that much energy. But to remove the third, that is where you're going to see a large jump in energy because I'm now removing a core electron. So there will be a large jump between the second and the third ionization energies simply because calcium has 2 valence electrons, and that third electron is a core electron. And remember, the reason why a core electron requires so much more energy to remove is because it's that much closer to the nucleus, causing a greater attraction for electrons.